Why is SEM important for failure analysis? Imagine trying to solve a mystery where the clues are so tiny that they are invisible to the naked. That's where scanning electron microscopy comes into play. This tool is like a superpowered magnifying glass that lets scientists see at the microscopic and nanoscopic levels. It's essential for failure analysis because it reveals details that other microscopes simply cannot. When products break or fail unexpectedly, it's often because of tiny flaws or defects hidden deep within the material. These flaws could be cracks, contamination, or irregularities on the surface. With scanning electron microscopy, investigators can see these flaws clearly and understand how they started. The high resolution of SEM allows us to see features as small as a few nanometers. That's a billionth of a meter. Such detail is vital in industries like electronics, aerospace, and medical devices, where even the smallest defect can cause big problems. Using SEM, failure analysts can examine fractured surfaces to determine if a failure was caused by ductile or brittle fracture. They can also inspect thin coatings or electroplated layers for cracks or imperfections that weaken the material. Sometimes, failures are triggered by tiny particles or inclusions that are invisible without SEM. By analyzing these particles, scientists can find out if contamination or corrosion played a role. Another key benefit is that SEM can provide compositional information. This means it can tell us what elements are present in a defect or particle. Knowing the material makeup helps identify issues like corrosion or contamination. It also helps in understanding how the material's microstructure influences its strength and durability. Failure analysis often involves studying the microstructure of a material. SEM makes it possible to see grain boundaries, cracks, and surface features in great detail. This helps pinpoint where the failure started and how it spread. It also helps assess if manufacturing processes introduced weaknesses or if the material degraded over time. In practical terms, SEM allows failure analysts to quickly identify the root cause of a problem. This can lead to improvements in product design and manufacturing. It also helps prevent future failures by catching issues early. SEM can work together with other tools like energy dispersive X-ray spectroscopy to give a complete picture of the failure. Think of SEM as a powerful investigative lens that uncovers hidden flaws invisible to the naked. It turns tiny defects into clear clues, helping us understand why products fail and how to make them better. This detailed view is what makes SEM so important in failure analysis and investigative techniques.